So we're going to demonstrate a distalizing root bend for example, for a lateral position. So here's Dr. Roshan showing a bend. So maybe just do it over the...
So here we have the position of the central. The central is here, the lateral is here, and we want to distalize the root of that lateral. So we want to do a step bend, second order bend, going up on the mesial of the lateral. So basically, I take my ribbon plier. If I want to go up on the mesial of the lateral, I have to push the wire down. And I have to push the wire up on the side of the central. And that'll give me my second order bend to move that lateral's root distally. Let me accentuate it a little bit. So if I want to move the lateral's root up on the mesial, I push down. And then I push up on the side of the central to get that step bend.
And then if you put it on the table,
It has to be flat.
It lays flat.
So you gotta make sure it's flat.
Awesome. So then you don't have to reposition the bracket.
That's right. Now, at the same time, you want this lateral's root to go up towards the distal, but that lateral, you want it to sink in as opposed to the central. So you want to do a step bend of the first order in and out to indent that lateral inside the arch. So you're still starting at the mesial of the lateral, and you want the mesial of the lateral in, so you're going to tip it out. Not up, but out. And you want the central on this side out, so you're going to tip it in. Now, the lateral, the distal of the lateral, you want in, so you're going to move it out. And then the canine, you want it out, so you're going to tip it in.
So looking from the top.
So looking, that's your first order bend.
Put it on the table. So
You've got a little, maybe 1/4 millimeter in step, so the lateral will be a little bit more lingual than the central and the canine. Also, if you look at it from this angle, you'll get your second order bend to tip that root distally right here.
The first order bend is more for
The first order is for horizontal movements,
when the tooth
in and out.
is smaller too, right?
Yeah, and it compensates for your poor bracket positioning and also for a bolt-in discrepancy of the size of the tooth. That is not exactly what was predicted in the torque of the bracket.
Okay. All right. Very nice.